Good day, doctor and my fellow friends. I'm Sammi Voon with the metric number of 76688, and today I'd like to do a presentation on the topic clustering analysis on autism spectrum disorder screening among the children and adults. So without further ado, let's get started. So what is autism spectrum disorders? Autism spectrum disorder is actually a common and diverse condition that affects the development of the brain and central nervous system. ASD symptoms include communication issues, repetitive routines and restricted interests, and difficulties in daily activities. Individuals with ASD are predisposed to ASD comorbidities such as genetic problems, neurological diseases, sleep disturbances, and gastrointestinal concerns. The data mining technique will be used to determine which clustering algorithm perform the best in identifying groups of people with autism. So what do we know about data mining? Data mining is actually a technique for extracting meaningful information from a large data set, also sometimes known as knowledge discovery process. So in the selection phase of the KDD, the data relevant to the analysis task is initially selected from the database. Preprocessing data removes the noise and inconsistencies from data and combines several data sources. During the transformation process, data must be turned into useful forms. Data mining, on the other hand, is a process of extracting patterns from data using proper algorithms. The interpretation phase converts these patterns into knowledge by transforming useful patterns that humans can understand. Studies have found that most ASD individuals are diagnosed later in life, which can cause serious consequences to them, especially women, as they are better at burying their problems, thereby causing mental health issues. Moreover, the traditional assessment for ASD has also caused in the delay in the intervention program, and even false diagnoses result in comorbidities among the ASD individuals, hence increasing the potential problems of ASD. This project is inspired by a few studies. Firstly, Schuver and colleagues whom aim to employ an accurate prediction model based on random forests in order to gauge important data on the behavioral attributes of the individuals with ASD. Moreover, Mata and colleagues have shown the use of knot-based resilience clustering, which is NBR classed, to understand the variety of ASD and discover significant subgroups that contains important biomarkers and thereby offering a better insight of the phenotypic heterogeneity in ASD. This project is also motivated by Battle, who proposes a new clustering technique named outlier-based multi-cluster overlapping k-means extension, in short, OMCOG. The proposed technique was tested on autistic trait screening to improve the identification of ASD features and reduce feature redundancy. The dataset that have been used in this project is retrieved from the UCI machine learning repository, which are the autistic screening dataset for both child and adult, where the child dataset has 292 instances and that of adult is 704. This slide right here shows the attributes of the dataset, which is exactly the same for both the adult and child datasets, where there are 21 attributes in total. As the datasets were downloaded from the UCI machine learning repository site in the form of .data, the file is then saved in the TXT file for further conversion to ARFF file extension. To ease the conversion, the Java code has been used to convert the .txt format to ARFF file. After the conversion, it is noticed that the relation and the attributes, as well as the data, are shown in the ARFF file for both datasets. The additional information is also added manually to introduce more about the dataset. As the datasets are now in the ARFF form, the dataset is ready for data preprocessing. Data preprocessing is defined as a step that removes the outliers and handling the missing values in order to ensure the reliability of the dataset. In this project, the missing values are handled with 3 different filters in the WCA, including replace missing values, replace missing with user constants, and remove with values. The attribute selection is done by remove useless filter, infogain attribute eval, and correlation attribute eval. Next, the data are treated with remove duplicates and subset by expression to remove noises and duplicated data. And lastly, discretization is also applied. For the child dataset, the remove duplicate filter is first applied, and it is noticed that the dataset is only left with 290 instances. The discretization filter is then applied to both the edge attribute and the result attribute into 3 and 5 bins respectively. The missing values in the attributes age, ethnicity, and relation is also handled by using the replace missing value filter, which replaces the missing values with mean and mode. Later, the attributes are evaluated by using the correlation attribute eval, and those that scored lower than 0.3 are disregarded during the clustering. This combination of filters yields in the best result, as it has only misclustered 18 instances in total. As for the adult dataset, the instances left after applying the remove duplicate filter is only 699. It is also noticed that this dataset is only for those who are above 18 years old and above. And in the age attribute, it is found that there are some outliers. This issue is then handled by using the subset by expression filter. Next, as the ethnicity and relation attribute has some missing values, thus the replace missing values are used to handle it. Discretization filter is only applied to the result attribute with 5 bins, and lastly, the remove useless filter is applied to remove irrelevant attributes, which is edge description attribute in this case. The performance of the simple k-mean is shown to have only 66 misclustered instances. After data preprocessing have been done, the dataset is now ready for clustering analysis. In this project, 3 different clustering algorithms will be employed, which are simple k-means, expectation maximization (EM), and MAC density-based cluster. The performance of each algorithm will be evaluated based on 4 criteria, which includes the number of iterations, number of misclustered instances, time taken to build the model, and lastly, the sum of squared value, SSE, or log likelihood. It is shown that in the child dataset, the EM algorithm took the longest and iterated the most, while both simple k-means and MAC density-based cluster iterated only 4 times. But simple k-means took only 0 seconds to build the entire model. Simple k-means is also said to be satisfactory, as its low SSE value indicates that the clusters formed are compact, as compared to the other 2 algorithms which have high and negative log likelihood value. As for the adult dataset, it is noticed that EM has the lowest number of misclustered instances, while simple k-means has the highest. Even so, simple k-means is the fastest to build the model. However, EM's log likelihood value indicates that the clusters formed are compact, thereby making it a better algorithm for this dataset. In the following slides, the visualization for the performance of each algorithms are shown, where the x-axis is representing the number of instances, while the y-axis is representing the clusters formed. The graphical representation of each algorithm is also shown in these slides right here based on different criteria, which includes the number of iterations, number of incorrectly clustered instances, as well as the time taken to build the model. As simple k-means doesn't have any log likelihood value, thus only the EM and MAC density-based cluster are compared in terms of the log likelihood value. The SSE value for both datasets are also prepared in this slide. Conclusively, data mining and clustering are a very powerful tool in this globalized era and is definitely helpful in analyzing the data to help researchers and even users to gain better insight of the current dataset. Through this project, I've had experience in the application of Weka tool and learned the importance of data preprocessing. It is also noticed that the different clustering algorithm will yield different results for each dataset. As for the evaluation of the clustering algorithm's performance, it is found that simple k-mean is a better choice for a child dataset, for it took the shortest time and that it iterated the least. The SSE value also indicates that the cluster formed are compact. As for the adult dataset, EM is considered a better algorithm despite its number of iterations and the time taken to build the model. It has the least number of misclustered instances and the lowest log likelihood value. However, the accuracy of the clusters formed can be further improved by using other clustering algorithms. As the application of the data mining have been widely applied in various fields, more effort should be put into the research field of ASD in order to gauge some useful information to promote early diagnosis and early intervention to take place. Thank you for your time and have a great day.